What's up? Well, this is your very own Bhavan Singh, and today I'll be creating another user requested program. You can see here that my project user request has been already been selected in my list, workspace list, and basically one of the user asked me to print the binary equivalent series according to the number of digits he wanted. So just stay tuned to this program, and I hope that you will be liking it. Okay. So to start off, just in the similar ways, just add a new file to this project, add files, and basically these are the files which have already been requested by my users, and I have already been made that. Okay, so just add a new file. We will be adding a new file. Do you want to add this new file in the active project? Has to be saved first, for sure. Yes, and just give it the name as you see. My code block project has been there, and inside that user request folder has been created, which containing the object and the bin files, and already one of the program was requested was here and the other one is here. Okay, so just to maintain the, no, I don't want to replace it. Actually, I want to just give it as program2.c. Okay, so basically to start off, first of all, a few things I'll be telling you is there are some limitations in this program, and what are those limitations? As you get through this program, you will be knowing it. And just one thing also I would like to tell you all is uh, the concept behind, what is the concept, actual concept behind the finding the binary equivalent of a number, of a decimal integer. Okay, so binary equivalent is basically we can say as it is the representation of a number in two digits we can say as in base 2. Okay, so the concept behind is very simple, and let me write the concept for you. What is the basic concept? Okay, first of all we will be dealing with the concept, and after that we can proceed with the programming actually. Okay, so coming back to the concept, it's really simple. Basically, what is it consists of the 4 steps to find the binary equivalent of any decimal integer. So the first step is divide the input decimal by the number 2 and store the remainder. So suppose there is a number 7, we have to find the binary equivalent of number 7. Then we will be dividing 7 by 2 and storing the remainder. The remainder in that case would be 1. Okay, so that remainder would be stored in some variable, you can say as, or any array, whatever you want. Okay, now store the quotient back to the input variable. Now the input variable would be, suppose the 7 is divided by 2, then the quotient would come out to be 2 threes are 6. Okay, so after that what will be happening, like divide store the quotient back into the input variable, then the input variable would be 3, and the process is repeated till the quotient becomes 0. Okay, and the equivalent binary will number will be the remainders in the above process in reverse order. So just to start it, example, for example, let me see, let me tell you all an example. For example, suppose the input and the decimal number is 13. Okay, so step 1 would be 13 divided by 2, and then the remainder would come out to be 1. Okay, and quotient would be 6. Step 2 would be 6 divided by 2, remainder would come out to be 0, and the quotient would be 3. In the third step, 3 would be divided by 2, and the remainder would come out to be 1, and the quotient would come out to be 1. And in the fourth step, when the 1 was divided by 2, remainder would come out to be 1, and the quotient would be 0. This is the I think that some of you might feel any problem in this part of the program, but it is not at all problematic. 0 is divided by 2 and the remainder is 1, so the quotient would come out to be 0. Now we have said that, as the above process says, repeat this process till the quotient becomes 0. Now the quotient is 0, we will be executing the fourth step. And the fourth step is equivalent binary number will be the remainders in the above process in the reverse order. So now the binary equivalent of 13 would be the remainders in the reverse order. So in the reverse order, not 1, 2, 3, 4, it would be 4, 3, 2, 1. So the binary equivalent would come out to be 1, 1, 0, 1. Okay. So that was the basic concept, and I know it's not at all hard. So just to understand and getting few, I know a few of might be already knowing this. So just to start off with the programming, let me remove this all for you and just start in the similar ways. So first of all, give the title of the program C program. One thing also, I'm not going to find the binary equivalent of a single number. I will be finding, like, I will be requesting the user that how many numbers you want, till how many numbers you want me to calculate the binary series. Suppose the user says me 13, so I will be adding I will be showing the binary equivalent of 0, then 1, then 2, then 3, then 4 till 13. Till 13 I will be adding the same procedure. So all the binary equivalent series would be printed in the right hand side of this program. Okay, because I know that finding the binary of a single number is an easy thing, but I will be doing it as per the user request that he wanted me to give the whole series. Okay, so let me start. C program to print the series of binary equivalent of decimal integer range. Okay, the second part would come out to be the author, that is Pawansan, and sorry, and final part would be the date. At what date I'm coding this? 04/09/2016. Okay, so let me start off the program. I will be coding it in a module parts. Okay, so just trust me, at the end of the program you will be having the clear understanding of each and every aspect of this program. Okay, so let me start. Here what we are wanting, here the user said like I want like exponent, like 2 to the power 2 to the power 14. He said that I wanted to print the series till 2 to the power 14. So here is a mathematical functions we have to calculate accordingly, and so we'll be using the header file. First of all, hash include stdio dot h. Okay, hash include math dot h. Okay, now first of all I will be creating a function. Basically this program, in the last step which I showed you in the example, it was a repetitive process. You were seeing that again the same thing was happening, division and then calculating the remainder and then storing the quotient. So it's a repetitive process, so I will be adding a recursive function. So what is the recursive function? A function which calls itself till the condition of execution become false. Okay, so it's a, although it's a bookish language, but still in the concept I will be showing you again. So here the range of the numbers was a quite a long thing. Okay, it was a quite long thing. So what the user said to me that I want large numbers to be calculated. So I said okay, no problem, I will be making it on that way. So just define a long convert to binary, convert decimal, let me say decimal to binary. Okay, so int, and this function would be simply taking an integer which was given by user. Okay, it's not that all. First of all, let me just zoom it out for you a bit more. Is that visible? I hope so. Okay, leave it. Int main. First of all, what are the things, what are the variables which we will be taking? First of all, the number itself, and then just define a counter, and then the power which was, I said na 2 to the power 14 he said, so I said okay, no problem, 2 power option, and take another option, just a simple, what is the use of it, I will be telling it afterwards. So first of all, give the message to the user, printf enter power to which you want to print the binary series. Okay, and then just go in the similar ways, scanf percentile d. For integers we are using percentile d, so here we are asking the power, so we will be using the power variable only. Okay, and how the number would be calculated, number would be equivalent to power function and 2 comma power power. Suppose the user enter 8, so the number would be 2 to the power 8. That is the thing. So first of all, for counter we have taken the counter na counter, where oh sorry, we have taken the counter which would be used, counter equals, so 2 to the power, here the output would come out to be 2 to the power 8, so we will be running the counter till 2 to the power 8, that is till number. So counter would be starting from 0, and counter would be starting from 0, and then what we will be doing, just simply counter less than number. Okay, and then counter plus plus, the counter would be increasing. So here what we will be doing, we will be recursively calling our converting function, printf percentile d in decimal equals percentile d in, here we have the binary was denoted as long, so here percentile d won't work, percentile double ld would be working. Okay, because the binary would be a large number. Percentile d comma, now first percentile would be denoting the decimal, so decimal would be counter. Okay, and the second function, second part binary, that binary would come out from this function. Okay, so we will be just giving the function name convert. Okay, convert to, and in that what we are giving, the counter value. Why, let me tell you why we are giving the counter value. See, when the value was, suppose 2 to the power 4 was there, 2 to the 4 to the 8 to the 16, till 16 we have to calculate, till 16, from 0 till 16. So what we are doing in that case, suppose let me start it from 0 to number. Why I tell you, I'll show you. So 0 to 16. So from that what will be happening when we are, suppose we are calculating the value for number 1, counter would be 1, and in that case here the decimal would be 1, and the binary for the decimal we have to calculate, so it would be coming out from this. So in that what it is going, the counter value was at that time was suppose 7. So 7 we will be, this function would be giving the value for 7. So even if you don't understand this point, just keep following. I'm sure that I would be able to explain you in a much better way. Okay. So after that, just give a return statement and 0. Just so that was all the part for the integer. Now we will be working on this function. So how we have to work? Just start long convert. Okay, in that integer number variable is long. So we have, now what was the process? We have to divide it by, first of all we have to divide the number by 2, and then what we are doing, we are just repeating the process till the quotient becomes 0, and then printing the number in the reverse order. So that was much easier. So in that we will be defining long binary number. Okay, equals 0. Initially the counter would be set for the number would be 0, and then simply we will be adding, after the calculation, repetitive calculation, we will be adding the same thing in this number. Okay, so let me start and define integer remainder. It's already a predefined math function, that's why it showed me, but we will be making it by our own. We won't be using that function. Comma initial, some initial like a counter would be set to 1. Okay, why? So now just put the while number is greater than or equals 0. Okay, then see remainder would be equal to number divided by modulus, not divided by. We have to calculate the remainder now, that's why. Okay, and then the number is again divided by 2. So how we can write it? In the number divide equals 2, use the short trick. Instead of writing the whole thing, binary number will be equal to binary number plus remainder into I and ITIAL initial. That's why it didn't show to me. Now it will be showing initial. Okay, and the last step would be simply multiplying the initial value asterisk equals 10, initial value into 10, and then return binary number. Now comes the point. Let me run this program for you. This was a simple thing. The number was divided by 2. The number remainder was calculated till the number was greater than or equal to 0. This part was showing that till the quotient becomes 0, this part would be executing. So remainder would be calculated, again the number was divided by 2, the binary number was calculated, and then again adjustment was done, and the again same repetitive process was done. So let me run this program for you, whether see it comes out to be. Let me give a minute idea for you all. Okay, so anything is there inside. First of all, control S. to save the program, debug and run. So very childish thing. It happens, no problem. We are human beings. Enter the power to which you want to print the binary series. So let me enter 2 to the power 4 only. I was saying, let me enter 4 for you all. Anything comes out? Oh, so earlier there was some bit program error, so I was not able to run that program for you. So now let me run this program again for you all, and the program would be the easy way. Okay. So welcome back. Earlier there was a bit of problem with my machine and I was not able to run the program for you all. But let me run this again. I have corrected all the problems and let me run this program again for you all. And just simply build and run this project. Enter the power to which you want to print the binary series. Suppose let's take an example 2 to the 4 to the 8 to the 16 to the 32 to the 64. Till 64 I want to print, that is 2 to the power 6. Just enter 6, you see. Till 63, it is coming till 63. Why? Because it's starting from 0. So even if you want 64th number, you see the binary decimal for 2 is 10 in binary, 3 in decimal equals 11 in binary, 4 in decimal equals 110 in binary. So you see the output is correct. Let me make this output a bit more visible better for you all. Backslash t and then backslash t. It's a tab. I'm just giving a tab so that it's much more better visible for you all. So let me run this program again for you all. Enter the power to which, just enter 6. You see it has came now. So now 0 in decimal equals 0 in binary, 1 in decimal till. Now it is coming till 63. Let me do this for 64 also. Equals. One more time. Control S and then run this program. So let me run this time for 4 only. For 5, let's see. 32. 2 to the power 5 equals 32. So that's why you see it's coming. So now from 0 to this, I'm printing the whole series. Okay. So that was the thing. And now here comes the main part. Till here it is completely okay. But one thing is, suppose I wanted to go above 10. Now, suppose I enter power above 10, 12. Okay, so now you see it is not coming in proper way. 4096, it's not coming in proper way. Till 10, let me check whether it is giving the correct answer or not. 10. You see 1024, even for 10, it is not giving this. Why it is not giving this correct? Let me tell you. From 0 to, no, I don't want to just clean this project. You see, now give me 10. You see 1023 till here it is coming out to be in this way till 728 and all that. The limitation is, so I was saying about the limitation at the start of the program. So the limitation is the machine won't calculate, not easily calculate. The GCC compiler range is till to the power 10. Okay, till the power 10 it is it will be calculating and giving the correct thing, no problem. Don't start the counter. Now start with this and equalize with this. Control S. Now run this program again. 4. Okay, you see now it is absolutely fine. Actually last time the problem was happening, I was starting with the 0, so that's why the second last number was not coming correct. So now everything is correct. Now here is the problem. Let me see. Let me enter 850. You see execution won't be happening. Okay, so just to avoid this, the GCC compiler range is till power 10. So let me modify this program in a bit more format so that it is much more visible or much more clearer to you all. So in that what we are doing, if P power range is, if P is greater than 10. Okay, just pop up a message to the user like printf, it will go out of the range for, let me show you somewhere it was written also. It shows that whenever you do a power greater than 50, it shows that it is going above the power range of GCC compiler. Okay, it will go out of the range for GCC compiler. Okay, just give this message to the user for, ask his choice that would you like to continue with different power. Huh? Then takes his input as press 1 to continue, or backslash n with a new line, or press 2 to exit. Okay, just end this statement. Let me do this in the caps for you all. Continue. Hmm? So what we are doing from here, we are just giving the user based on that power. If p is greater than 0, that is the power is greater than 0, or sorry, is greater than 10, then just simply print the message to the user like, and then what we have to do, the next step, suppose now the user will be entering either 1 or 2 or anything which is not desirable. Okay, so in that case what we need to do, the next step is scan, the next step is scanf, scanf percentile d, comma. Now you can see here why I have given the option word, option. Okay, in that if, just give a braces here, and the closing would be coming where I will be telling, just go it with the flow. Scanf, now the option. Now the option has been given to us. Now again we have to check if option double equals 1. Okay, that is the user asks us to continue with different power. Then we just simply have to go to a particular statement. Which statement? Like we have to change the power. So we have to go to this statement. Now many of you might have heard about a statement called jump statement. If the option is 1, then we have to jump our control from here to here. So how to define a jump statement? Like go to, just give the label to this line. What is the label? Would be input 1. Okay, give it as this. Now this line has been defined. Okay, or it is better, like we have given the label to this line, from here we have to again execute now. If the option is 1, that is the user is agreed to continue with the printf statement with the different power. Okay, so we will be starting from here only, and then what is the thing, just give one statement, go to, what is the label, input. Now the program control would be directly going to this part rather than executing. Now if option double equals 2, then what do we have to do? Like we have to go to this statement, that is return 0. We have to just exit. That is the user doesn't want to do anything ahead. He just want to simply exit from the program. Okay, just give a backslash n for more visibility. Option 2, then simply go to exit. Just give this a label, exit this line a label. A label is defined as, take the statement, full statement, just give the label name and then use a colon, exit. Okay, it would be simply moving our part to exit. Just give here, although it's a single statement, we don't need to use the braces, but still, just to avoid any kind of confusion. Last part would be else. Suppose the user and neither enters 1 nor enters 2. He enters something else. So we have to pop up a message to the user like printf, please enter a correct option. Okay. In that, what do we have to do? The option is entered in this statement, in this. Okay, the option is entered in this, the power is entered in this statement. So what do we have to do? Just define a label to this statement, input 1 colon. Okay, scanf, just go to input 1. Okay, so now the program control would be directly transferred to this part. Suppose the user, now let me explain this again for you all. Suppose the power comes out to be greater than 0. First part would be executing. It will go out of the range for GCC compiler. Would you like to continue with the different powers? Press 1 to continue, press 2 to exit. Okay. Now suppose the user enters 1. Now again this part would be checked. If option double equals 1, the option value comes out to be 1, then simply we have to go to this part, that is enter the power to which you want to print the binary series. Now the second part was, suppose that the user want to go out of the program rather than doing anything, so just he will simply press 2 to exit, and then it would be go to exit, and finally where we will be coming, we will be coming at this part and return 0, and there will be nothing, no print out, nothing. The third part, suppose he enters 3, 4, 5, anything other than 0 and 1, then simply what we have to do, just pop up a message to the user, please enter a correct option. And then if he enters the correct option was taken from this line, input 1 label. So we are going to go to input 1. And the rest of the part is same. Okay, I haven't made any change. Just let me run this and try again whether it comes out or not. Okay, expected a declaration statement at the end. Okay, that is the thing. Let me see. If this if was here, just a braces for the integer. You see, now one time let me run this in below 10. Below 10 is 4. No, 4 we have run 9 times. 6. Press any key to continue. Why it is showing so? Okay, that is the thing. Any error has came out. We haven't made a big change, but it should come out. Power counter, input 1. Okay, control S. It is not showing any output. Why? If power is greater than 10. Okay. Okay. Whether I have made any change? Exit. Printf counter is here only. Else, this else is fine. Okay, this else is fine. Oh, one statement has to be reduced here, no? This if was not closed. Okay, this if was closed here. That is the reason last time that output was not coming. So it's nice that we are able to crack the problems and we are able to solve it as soon as possible. So let me run this, try this again whether it is coming or not. Just remove this from here. Okay, control S. Now 4. Yeah, this is the correct thing. You see, I have entered the 4. It shows the series still here. So now let me enter control S again and run this program for you all. Now let me enter 15, 16. You see what it is showing. It will go out of the range for GCC compiler. Would you like to continue with a different power? So let me start 1. Okay, some error is showing. We are not able to track it. And let me try this again for you all. Control S. 13. So to exit, it is not showing. Okay, no problem. So for the time being, I have told you the limitation about this, and I will be again working on the same program, and I will be producing the updated version of this. Just for the time being, till 2 to the power 10, you can use this code. If you know that you will be using that code for power less than 10, just simply remove that part till here. Take a control X, just simply remove that part from here and just execute the program till power 10. I will be again coming back to you all with a new updated version of this program, in which, hope so, I will be using the powers above 10. Okay, so that was all from me for the day, and just stay tuned to my channel, and if it is helpful to you at all, just give appreciation. That's it. Thank you. Bye bye. Have a nice day.